Welcome to the next video lecture of the control systems. In the before video, we learned about what exactly the main elements which are required for the control systems, like input, output, actuators, and controllers, and feedback, which and everything we learned. Now we are going to learn about the actually what are the types of control systems. There are two type of control systems are there. That is one is related to open loop system, so open loop control system, and in that open loop control system, what exactly will be there means there will be no feedback will be there. Okay, the feedback will be there, and also input will be there, controller, and after that the process or a plant will be there, and also the output will be there. This is the only thing. There is no feedback signal which is going to come back towards the input or to controller. So that will be acting as the open loop control system. For a best example in a real life world, it will be as a washing machine. And advantages are it is very simple and also very cost effective. And the next one is about related to so what are the disadvantages related means there will be no control will be there, and also there will be accurate. For example, if we want a certain value means that certain value may come or may not come, or it may go beyond the things, or it may go very less also. So that will be happens in the open loop control system, and the no error corrections will be not happen. So no, when there no control is will be there, so the no corrections will be there. And if we want to see the exact the block diagram of a open loop control system, this will be like that. For example, as I already said, like it as a the input will be there. Okay, input or reference signal will be there, and after that input transducer, that means input the whatever transducer, here we took it as an example as a system, and this is called transducer output signal will be there, and controller, and the disturbance and processing output signal. That's it. There is no nothing will be there. It may be like it as a just to see what are the disturbances what we are getting, that things. These are like it as not an open loop system. It is a semi open loop system, we can call it as. If the only open loop system we want to say is up to this only, we will call it as a complete open loop system block diagram. But there are some open loop systems people will call it as a, they will call in this adding this thing also call it as a processing, to give a better output, like it as a digital outputs or analog output. To get that output things, they will arrange this processing plant also to get the desired things. Okay, and the next thing is we will go to the closed loop system. So the next one is the closed loop control system. In the closed loop control system, what exactly the difference will be there means you will get a feedback system and also a comparator, and the controller will be giving the acting as the actuator. The best example is the air conditioner. If we the air conditioner, if you see after a certain temperature, for example, if you set a temperature of 18 degrees or 20 degrees like that, then automatically what will happen if the room temperature is less than 20 or nearby to 20, then automatically the air conditioning, the whatever the cooling, whatever the coolant equipment will be, that a coolant equipment will stop working on the front, then until the temperature is rising the beyond the things, then after that only then again it will comes to operate. So this is how it is maintaining that the room temperature need to maintain up to 20 degrees only. If it is going less than also, again it will stop and again it will come. So this is how it will happen, sir. So here if you see means the most advantage, sir, like it as a, they are very accurate, and auto correction will be there. So as I already said, in the air conditioner, if we have an auto correction, then automatically this auto correction will be happen. But the disadvantage is this very costly and also complex. Why complex? Because I will show you the block diagram now, you can understand what exactly. So if you see, so this is the error detector, right? This error detector, and that error detector again we need to modify, we need to control, and after that whatever that error, whatever it is, that need to be sent to the controller, which will be act, and also controller controls the signal, and after that, as we already know, actuating the signal, and after that it will be sending to the plant. So once the plant is giving the controlled output, again it will check iterative process. That means it is not stopping at one time or a certain time like that. It is continuously, it will take the until unless you stop the loop, or until unless the system is stopping or any breakage was happened, this system is continuously, it will flow like this only. There is no nothing differences will be there. So it is happening like that. So this is how the what are the complexity, the complexity mostly lies in the this part only, controller, reference signal, there one, because these two are nothing, we can't able to do anything. So because this has plant is already fixed one, we can't do anything. And the feedback signal, it is just like another, it's a collecting signals and it is giving back to the control. This is what it will happen. So the only disadvantage, complexity will happens only here only. Okay. And the next thing is, we will see first what exactly the basic comparison between open loop and closed loop. So once the as we already saw, so there is no feedback signal will be there in the open loop, but they in the closed loop we will have the feedback signal which will be used to control. So that's how it is become a less accurate, and that's how it is become very accurate and adaptive. That means time to time it will take the reactions and it will get the output to be controlled. Okay, this will happen in that way. And the next one is real world examples, because we need to see where exactly the real world examples happen. So if you see the open loop system is, we are having a toaster, that means a bread toaster which doesn't have anything, whether the bread is heated or not, whether the bread is toasted correctly or not, it doesn't care anything. It will see that temperature and it will send it back. That's it. In the washing machine also the same. If the washing machine doesn't see like it, whether it is the whatever the dirt is removed or not, that is also not happens. So the next one is the closed loop. In the closed loop, cruise control or AC. Cruise control means simply like a bike, like EV vehicles or that one. So this will happen the real world examples. So the next one is just a second, real world examples. And the next thing is conclusion. By this thing, end of this open loop and closed loop comparison based things. So what we can control is, for a control system, the automation is very necessary, because automatically it need to detect, automatically it need to correct, automatically it need to take decisions. That is very much essential nowadays. So that is not possible in the open loop, that is only possible in the closed loop only. So that's why people always prefer the closed loop system. So this by this end of this video, you can get to understand like the closed loop is most advanced and most used thing in a any field, like any power electronic power systems or machines or whatever electrical mechanical control also. So in the next video we will see the applications of control systems in electrical field. Thank you.